This is Module 10, CFD of cylindrical vessels. It consists of radial heat transfer in vessel walls and flow and heat transfer in vessels. This is Module 10.1, radial heat transfer in vessel walls. First, create a vessel, as you did in Module 4, with similar dimensions as presented on this screen. Go to the Flow Simulation tab, create a lid, click OK. Assuming that this is liquid inside, let's extend this. This will be the section view of the geometry we're going to work on. Click OK. To deactivate section view, click section view again. Go to Flow Simulation tab, create a new, save this geometry first. Go to Wizard, create a new project, create new configuration, click Next. Let's use SI, and we can edit this to Celsius. Click Next. For this, we're going to use both fluid flow and conduction. So make sure to tick that. We're going to use transient simulation as well for 1 minute. And the time step will be every 1 second. So it will collect data every second for a minute. And for the gravity, along the y-axis, let's set the gravity. And along z-axis, it's 0. And since the liquid is inside the cup, the analysis type will be internal. And make sure to tick the box on this, on exclude cavities without conditions. Select Next. For this, we're gonna assume that the liquid inside is water. So let's add water. Select Next. And the solid material, the vessel, we're gonna use alumina typical. Let's set this as the default values, and the fluid temperature, let's set it for 25 degrees Celsius, and for solid temperature as well. Select Finish. This is the computational domain. You're gonna see here at the input data, that's gonna set the boundary conditions. If you can't see the boundary conditions, heat sources, or initial conditions on this area, right-click the project's name, customize tree, and select here what you want to do or the tools you want to use. For this simulation, we don't need heat sources. You will notice that it will disappear when you do that. For this simulation, we're gonna set boundary conditions. The outer wall, select this. We're gonna set the outer wall heat transfer coefficient to be 25 and the outer wall temperature to be 25. For this, the surfaces we're gonna select are the outer vessel and the inner part of the vessel. Select OK. And the initial condition, we will need to select the inner surface of the vessel because that's where the liquid is in contact with. So do a section view, click OK. Set the initial conditions. This surface and this surface and the surface of the lid below will be let's say 80 degrees Celsius. I forgot to mention for the outer wall, let's also include the lid on the upper side. Now, run the simulation. Use all of the default options here, then select Run. A solver like this will appear. If you can see this, click Insert, Preview, select what plane, and what type of parameter you want to see, and it will display as such. Here you can see that the solver is finished. Minimize this. Let's go here to the results. Click the plus sign beside it. And we're gonna use cut plots. Click Insert. We're gonna use front plane, but you can also use top plane, right plane. But for now, let's use front plane. And the parameter we want to see is the temperature change. And select contours. Click OK. You can see the temperature changes when the liquid inside is 80 degrees Celsius and the walls of the cup is at 25 degrees Celsius. You can also animate this. Right-click Cut Plot, select Animation, select Wizard, select Delete all existing tracks, click Scenario, and keep this at default. Click Finish. You can see here the cut plot. Go here and right-click Go here and right click, insert control point. Drag until the end of the simulation, until the end of the animation. Click play. You will see how temperature changes along the liquid and the solid. For this video's mini task, probe around the temperature cut plot and determine which parts of the vessel wall has the lowest and highest temperature. This is the end of Module 10.1. Proceed to Module 10.2 to learn how to visualize flow inside vessels.